So digital radio is a direct drop-in replacement for FM systems. And you're probably aware of some of the trunking systems that have been around for many, many years. They're based on FM. The idea is that the trucks or the handhelds can wander all over the country and you don't have to worry about channels and frequencies. It just finds the best channel for you. And you can call the radio like a phone. So you can contact an individual radio or you can do a group call. So that's the history of what trunk radio is all about. Now land mobile is, you're all aware what the difference between land mobile service and the amateur service is? So to make that fairly clear. So land mobile service is all about commercial radio, and the amateur service is about, we've got a chunk of spectrum, whatever we do in that chunk of spectrum, we can do whatever we like, pretty much. Okay, that's what our licenses allow us to do. In the land mobile areas, you can't do that. You've got to have channelized radios and non-front programmable, front panel programming, so FPP, you can't do that. You can't just type in a frequency, you've got to use a channel. That's a big difference. It's important I say that because a lot of how these DMR radios are set up come from the commercial world. So there's some terminology differences. So just recently there's been a restacking for commercial radio systems. They've gone from 25 kilohertz spacings to 12.5 kilohertz spacings. And you're probably wondering why they're doing that, because the 400 meg and the 800 meg spectrum is really, really valuable. So they're trying to cram as many services as they can into that one allocation for the business band, as they call it. So most commercial offerings now 12.5 kilohertz, not 25 kilohertz like we're used to in the hemisphere. And as I said, the spectrum in those bands is very expensive, particularly in Europe, because it's such a densely populated area. Not so much in country areas of Australia, but definitely in the capital cities. You try and get a 400 meg allocation now, and you really got to fight for it. So in the land mobile space, these are the ones that I'm aware of that are used most common. Now that's not an exhaustive list, but the DMR is probably the number one because it's the cheapest. I know for a fact that Kangaroo bus lines use that. So you see the Kangaroo bus lines around, they're all DMR radios in there. Am I out of shop? Sorry, John. So little d MPR is the cheaper version of DMR. So it's used a lot in the family mobile radio service and the general mobile radio service, which is more popular in the United States. So they're cheaper, little tiny little like UHF-CB type things, but they're actually digital. It's not compatible with DMR. P25, P25 or Project 25 or APCO 25 is probably the next most popular of the commercial digital radio offerings. So Ergon Energy use that, and it's also used in a lot of the government wireless networks around Australia. So the GWN in Queensland is a P25 phase 2 system. And then there's Tetra. So Tetra is a European making standard, and you see the Brisbane City Council buses are all Tetra. So when your cheap shit little amateur radio goes berserk next to VCC bus, that's because the Tetra radio is going burst all the time. Okay?
And it's also encrypted too, isn't it?
It's digital.
Yeah.
Yeah. So that's what I have to mention too, particularly with the GWN, because the coppers use it and other services use it. It is encrypted, and you need a privacy key, so you can't just listen to it.
If you get one and break it, it creates another one on top of it.
Yeah.
Straight away.
So from the top, DMR is really a Motorola thing. P25 came out of a consortium. It's mainly led by Tate. They're probably the biggest manufacturers. But Motorola and a few other manufacturers do P25 radios. And Tetra is pretty much only Motorola. And the NXDN is the ICOM, not the amateur ICOM, but the commercial ICOM digital flavouring. So in the atmosphere, what have we got in digital radio? Well, I think we all know about D-Star, or digital system for amateur radio or something like that. It's a JARL, so it's a Japanese Amateur Radio League invention, basically, which they've freely licensed to the amateur world. But the only manufacturer that's taken it on in a big way is ICOM in the amateur space. There is a Kenwood radio that does D-Star, so that's open if you want to do it. Then there's what I call Fusion, which is C4FN. So that's the Yaesu flavouring of the digital radio, just what we need in the amateur space, another modulation technique. DMR, which is mainly Motorola, but there are a whole bunch of other manufacturers who are doing it now, and I'll get into that later on. And P25, so there are P25 repeaters around southeast Queensland if you want to use them in the amateur space. And you can pick up P25 radios for a reasonable cost. They are expensive brand new, but you can get second-hand ones that are not too bad. And then there are some people playing with NXDN with Icon professional radios in the amateur space. I don't know actually, I've never played really with P25 or Fusion or NXDN, so that's where my knowledge stops. So don't ask any questions. Okay, so as I said, I'm going to focus on DMR for this presentation because it is the cheapest way to get into digital radio. So you can get a radio for about 130 bucks to get into DMR. So I had a question last week actually from Bob. He said, what's the difference between Tier 1, Tier 2 and Tier 3? And I said, oh, I don't know. So I researched it. So can you read that tiny writing? I didn't realise how small it was. So Tier 1 started is in the 446 meg band, and in Europe that's a license-free band. So you can just get cheap Tier 1 DMR radios, but they're only radio to radio, no repeaters. So they're just a simplex to simplex. The Tier 2 allows operation from 66 to 900 megs, so you've got a whole bunch more frequencies to use. You can use repeaters, and it's a direct drop-in replacement for FM. That's the big thing. And you can have up to 50 watts in your mobiles, which is for cars is very, very important. And DMR Tier 3 is basically everything that Tier 2 is, but with trunking. So remember I was talking about trunking before, how you can drive around and your radio, you don't care what repeater you're using and what channel you're using, it finds the best way to talk. That's what trunking is. And it does packet data as well, so I'm quite keen to see that. So it does IP traffic over the radio, so you can do IPv4 and IPv6 type comms as well as the digital voice. Haven't seen Tier 3 in the amateur space just yet, so it's only just fairly new. And I found a fairly good tutorial about it at this web link, and again I'll get John to send this out if you want, so you've got some web links about what the actual comparison is. But everything I'm going to talk about is Tier 2. So everything you buy in the amateur space these days is Tier 2. If you buy a Tier 1 radio, you've wasted your money. So that's first note. Okay, so into what DMR is actually, what it is. It's 12.5 kilohertz wide, as I said, so it's compatible with FM systems now, so you can grab an FM repeater allocation right now and replace it with a DMR repeater. Drop in. Okay. The big thing about DMR versus other digital systems is there's two independent time slots. And what they mean by time slots is that you've got two streams of data in parallel on the same frequency, which don't cross over. And within those time slots, you've got two streams of data going down the carrier. You can have time division talk groups in there as well. So you can have multiple talk groups on two independent time slots. And so effectively what it is 9600 bits per second over the air. And the modulation is 4-state FSK. I'll go into help the modulation is offhand that quite interesting how to do that. So you might wonder why commercial people are doing it. So in the past when they've tried to combine two 6.5 kilohertz channels on one antenna, using their one 12.5 kilohertz channel, they have to use a combiner and two radios. Now these boxes themselves, I don't know if you've ever priced them up lately, but they're scary expensive. Upwards of $25,000 to get them tuned properly. So that's not including the duplexes, you need two duplexes as well to get two frequencies out of the one antenna. Then you need two types of radios on two different frequencies. So they thought that was a bit silly, so why can't we do it in one? So they interlace the time, this is time slot 1, time slot 2, time slot 1, time slot 2. So they sort of interlace it every 30 milliseconds, they put in a different time slot. So the whole idea again is spectral efficiency.
Is there a delay with that, Peter?
I can't hear it. We'll do some audio stuff later on.
Yeah.
This is where I was trying to show Again, I'll just pinch these off the web. I'll probably get some better for them. So just the straight one channel is just data going out or voice going out on FM. And here we've got time slot 1, time slot 2, time slot 1, time slot 2. So that's happening very, very, very quickly there. You can't pick it up every 30 milliseconds. So just that by itself, you've got twice the spectrum. But then, with each of those time slots, you've got your talk groups as well. So you can get multiple conversations happening on the one time slot. Theoretically, as many as you like. Practically, I think it's about 4 or 5 before you start running out of bits. So it uses the modulation technique for DMR or any digital system is FSK or frequency shift keying. So it's basically going, this is your carrier here, and it's going 0, 1, 0, 1. So that's showing both bits active as 1, so that'll be a 1, 1. So it'll transmit those 2 bits, so that'll be 0, that'll be 0, 1. Down here it'll be 1, 0. So it just transmits 2 bits continuously. That's 2-bit FSK. So it's moving from one frequency to another, slightly around the carrier. So that's basic FSK. You all know that, hopefully. What's wrong, Charles? So FSK is the same as RTTY. PSK31, you're going from one tone to the other quickly. PSK31 is doing it at 31 bits per second. RTTY is doing it at 50 baud. From one tone to another, that's FSK. But what DMR does is it crams a lot more bits into the same spectrum. So you've actually got 4 bits. So each symbol transmitted ranges from 0, 0, 0, 0 to 1, 1, 1, 1. So you're doing that at 4,800 bits per second, 4,800 symbols per second. So each of those 4 bits is called a symbol. So you can imagine you can cram a lot more. You've got twice as much information all of a sudden because you're using 4 bits in the same band of spectrum as using the 2 bits before. So that's the same spectrum. We're using twice as much information now. So that's the real power of these digital systems. Again, spectral efficiency. That's what it's all about. The drivers.
That is the effect of producing down there.
Yeah, and that's one of the advantages that they go through one of these diagrams is it has 50% reduction in repeater costs and 40% increased battery life. And that's real. That is real. I've experienced that with my DMR radios. They're quite extraordinary. Done that one twice. Okay, so the heart of all these systems is the AMBE codec. That's a bit of silicon that's currently under patent at the moment. So one of the big objections that people had to D-Star is they use the AMBE vocoder chip, which is licensed to VSI, DVSI. So at the moment it's under patent, no one can copy it without getting in trouble. But it's only $3 US, so it's no biggie. They're pretty persuasive, these chips. There's one in my sat phone, there's one probably in a digital radio you've got in your car if you use Sirius, that sort of stuff. They're quite a commonly used digital vocoder chip. So again, I just did a wiki for what MBE stands for, multi-band excitation. The beauty of it is that no matter what modulation technique you use, you just stick the modulation into that chip and it comes out as audio. So all that thinking's done for you. Okay, so why? Why would you use digital over FM? Well, apart from increased battery costs, more spectral efficiency, better battery life, and cheaper hardware for your repeater sites, you get a much better signal-to-noise ratio. I'm probably not explaining it very well. But what this graphic is trying to demonstrate is as you get further and further away from the station, an FM signal will drop off until you start getting a lot of white noise. Digital signal doesn't do that. It goes right to the end and then bang like a switch, it's gone. Just goes like a light switch. Yeah, pretty much. But you've got almost 100% intelligibility until the drop off, whereas with FM you're getting a lot of scratchiness and, as we say, we're going into tiger country. So they're trying to demonstrate that there's several dBs of advantage of digital versus just straight FM. So you've got that whole area, you've got good audio quality right up to the edge. But then once you get to the edge, okay, so as I was trying to cover before, there's time slots and talk groups. So this is where the terminology gets a bit confusing with this DMR stuff. So we've got 2 time slots at 30 milliseconds, and each time slot can theoretically carry an unlimited amount of talk groups. Now practically that's not possible, of course, because you've only got a set amount of bits in your time slot. But I've seen on the dashboard, and I'll show you the dashboard later, 3 different talk groups going at once in one time slot. And you listen to each of those talk groups, and there's not a drop in audio quality at all. It's quite remarkable. And so users can't hear you on another talk group or another time slot, which is not precisely true, because you can set your radio on what they call promiscuous mode. I love these terms. So you can have a yeah. So promiscuous mode means basically you can listen on one time slot to all the talk groups. And that's pretty much an amateur only thing, because in the commercial world they don't want that. Because that other talk group and that other time slot may be another customer. It may be the police or another company, and they might be competing companies, so they don't want that. But it can be handy in the amateur sphere. If you haven't got the dashboard in front of you, put your radio in promiscuous mode, you can see who's on what talk group, and then change to that talk group to talk to them. That's the whole idea, is that because the 400 meg spectrum and 800 meg spectrum is so congested, they have to get more customers on the same frequency. That's the intent. That's where it's come from. It's not so important in the amateur world because there's not too many of us. But it is a bit of fun to work out how to make it work. Okay, so in the beginning, amateur DMR started out with DMR Mark, and that was Motorola repeaters only, no hotspots, no dongles. You had to put a Motorola repeater on the network to be permitted to use DMR Mark. And Motorola repeaters started around about $4,000, plus your combiner, plus your antenna, plus the internet connection. Pretty expensive stuff. So some Germans really got their shits with it, and went, bugger it, we're going to do our own network, and they called it Brandmeister. And it was formed because DMR Mark only allowed Motorola repeaters, and they thought that was against the amateur spirit, and I agree with them. I think that's wrong. So Brandmeister allowed anything on it, and as a result it was pretty rough and ready, and a lot of cowboys, a lot of problems, a lot of call problems, a lot of voice quality problems, but it was a lot of fun, because you can use just about anything you liked. The DMR Mark people started to realise, oh, no one's using our repeaters anymore. So then they formed this DMR Plus bridge to the Mark network, where they allowed other high-terra repeaters and other dongles to connect. All those DMR Plus and DMR Mark don't exist anymore. It's just called DMR, because now they've joined forces, recognise that you can't stop people playing around. It's the hobby of the hobby. So you won't see DMR Plus or DMR Mark referred to anymore. There's still no connection between Brainmaster and the DMR, the VK4EA or the IPSC bridge. Still a lot of politics going on, and I haven't got involved with it.
But you can use the same radio to communicate on any of those?
Yep. Yeah, the radios are the same. The big difference that it was with Brainmaster is it was a hotspot and dongles. So if you had any connectivity, you can get onto the network. But as far as I know, there's no Brainmaster equipped repeaters around this area. So as I said, as of today, they've combined forces, so now they're one. And the software is called IPSC2. So it's a bit of bridge software that a very, very clever bloke wrote to connect the repeaters all together. They call that the bridge. And they're the web links, and I'll show you those web links live. Before the presentation, you saw that screen up. That was the dashboard for one of the servers. So what have we got around the area? So Mancutha, VK4RMC, that's the one I use all the time, because I live at Northgate, so I can get to it. I can spit to the Mancutha where I am. But I was using it on the way up here in the car, so it works quite well. It's the RNX, which is run by these two repeaters are run by Sunshine Coast. Club. And all these repeaters are linked together thanks to Andrew Chapman, VK4EA. Probably heard that name a bit, but he's a bit of a repeater guru. He started all this off in southeast Queensland. All those repeaters are 70 centimetres. So most of the DMR radios you buy are UHF only, because that's, again, inherited from the commercial world. They don't use VHF in commercial too much. But there's also mixed mode repeaters. So those repeaters before were DMR only. These guys, locally, are what we call mixed mode. So VK4EA was one of the first 2 metre V-star repeaters around that Mark Cole put up at Wilkes Knob, the back of Mullaney. He's now changed into a multi-mode repeater, so he can do just about any digital mode. You key it up on P25 or NXDN, V-star or DMR or FM, you can use it. I think that's kind of cool. And same with Mount Cotton, so the Bayside Club have just put that repeater up as a mixed mode repeater.
At Bayside, Cotton and Mount Cotton?
Yep. Yeah, so south side of Lost Mount Cotton, both side of the back of the so yeah, the main reflector that links all those modes together. So the cool thing is that you can potentially talk to any digital radio user on different modes using that one reflector. So you connect your hotspot up to that reflector. You got a DMR radio, you can talk to a P25 user. That's kind of cool. That's the sort of stuff they couldn't do on DMR Mark before. Yeah, as I said, I don't think there's any Brainmaster infrastructure that you can use for mountaintop repeaters, so it's hotspot or dongles only. I don't have a lot of experience with Grandmaster. I haven't actually used it all that much, so I can't really talk about it with any authority other than that there's thousands of talk groups to choose from. So the talk groups are based roughly on geography, so there's a German talk group, there's a UK talk group, there's a New Zealand talk group or whatever, so there's all regionally based talk groups. So you don't have to know Italian to talk to Italians. Okay, equipment. So everyone asks me, oh, it's really expensive to get into digital. How much do you reckon?
60?
A bit more.
120
$120. And does FM as well, for you troglodytes who want to go back to Sparks. Chinese, everything. Of course it's Chinese.
Is it brand? Is it type?
So it's not type approved, so don't use it on CV.
Right.
Well, don't get caught using it on CV, I should say. But I've got FM repeaters set up in there as well as the DMR stuff, and for the hotspot, which I'll show you. So it's not expensive to get into. You can pick up second-hand DMR radios for $100 on eBay. Just to make sure they're T2, that's the only thing. The big difference between these guys is that you've got a program, and that's called a code plug. That's another term you might hear. As I said, there's plenty of commercial offerings. If you go to that website, go to that web link, there's a comparison of what works on the DMR network. So it's worthwhile checking out if you do find one that's about the price you want to pay. Just make sure it's on that list. This is branded Thai Terra, which is a rip-off of High Terra. So High Terra is a number 2 DMR manufacturer in the world, after Motorola. And Thai Terra went, oh, we're going to take some of that. They pinched the Motorola, the High Terra designer made that. So yeah, cheeky buggers. That's compared to my V-Star handheld, which cost me over $600.
$600.
Aren't they good enough? Casting up, they're expensive.
Peter is still on the warranty, 5 years.
Oh, good.
That one's waterproof, isn't it, too?
Yeah, this is a really nice radio. It's got a lot of features. Yeah, thankfully it's tough. But that's just a comparison. Okay, so that's an ICOM offering. That's V-Star. You've got one of these. Not cheap, but an excellent radio. I really love it. Can't use that in DMR, unfortunately. Yeah. Okay, so code plugs. I think I might have mentioned that before. With the ICOM radios and Kenwood radios, you can use the front panel, put a frequency in. You can't do that with these guys. You've got to program them, and that's where the fun is. And I think that's where the technical challenge is to work out how to make them work and how to program it so you can use it. So the actual operating themselves is really easy. You just turn a knob and select the talk group. It's really simple to operate. But for me, it took me 12 months to work out how to program them. You can't front panel program. Can't say that up to 10 years. So with every one of these DMR radios, you get a programming lead, and the software is almost always freely downloadable off the internet. Okay, so that's the challenge. Now, if you go and buy a DMR radio and you come to me and say you want me to program it, I'm going to tell you to go away. You should have a go yourself. That's the only way you're really going to learn, is to have a go and try and program it yourself. For me, that's the challenge.
And then come and see you.
Then come and see me, but only if you had a go. If you haven't had a go, I'm going to tell you that. John, you ready?
Go away.
Piss off. Alright, so terminology. So just go back to some of the terminology. Time slots, we talked about time slots. DMR has two, so that's time division multiplex. Color code. Color code is exactly the same as CTCS. Did I say that right? CTCSS, should know that I'm an examiner. And digitally coded squelch. So the 16 color codes, it's equivalent to that. So as well as having talk groups and time slots, you can have a color code for a radio, and that only keys up certain repeaters or certain other radios with the same color code. Same sort of thing. TX, contacts and RX groups, that's all about, again, the multi-customer idea on the same frequency. So when you press the button on a certain setting on your radio, it's only transmitting to a certain number of contacts. In our case, in the end of the world, it is actually a group call. So you're transmitting to the whole of the talk group, not just to pass the talk group. Similarly, when you receive, you may only want to receive from a certain number of radios, a certain group of radios. In amateur DMR world, it's just a talk group number for both. The big difference between this service and other services is that each radio or each user has a unique ID. Now that's kind of cool in that, so you get a 505 for Australia, it starts with 505 and another 4 digits. So 505 is the Australian radio ID start. You can program all your contacts for Australia and the world in your radio, so a call sign pops up on the screen when they key up. And your name. Can't do that with FM. I find that kind of cool, so it says when someone pops up, no, I don't want to talk to him. And similarly, I'm sure when I key up, I don't want to talk to that guy. So to register your radio ID is free. It's the same process as registering your call sign for DStar. Each digital mode has the same radio ID, so you get one radio ID, it's the same for P25, it's the same for DMR, same for NXDN and Fusion. Is that a store? Okay, so I've talked about repeaters. There's another way of getting onto this network, and that's with the hotspots. You've probably seen the hotspots before. I've got an example of several here. This is the first one I bought. It's called a VK4EA Mini. So USB port, it's multi-band, so it operates in 2 meters and 70 centimeters. Plug it into the USB port of your computer, or your Raspberry Pi, or your Linux machine, or your Mac. It doesn't matter. And you can run. The problem with this thing is it cost me $200 and it's now useless because the guy gave up on it. So I can only use it on DStar. So don't buy a VK4EA Mini. That was the message, but that's how small they get. There's another version of it called the AMVE stick, so that's what I've written here. I think David, VK4EA, might have brought one down. We were talking about him using a set of headphones and talking any mode. Yeah, so it's the same form factor as that, except it's got 2 jacks on it for your headphones and your microphone. So you don't actually need a radio. Antenna and deep on DMR. That don't work, unfortunately. So I had a spare extra dB mega, and I mounted that on a Raspberry Pi Zero. Now Raspberry Pi Zeros are $26. They're nothing. And the SD card was more expensive than the damn computer. So I got that Raspberry Pi Zero in the mail today. I took it home, and within 10 minutes I had the card flashed with the PiStar software. I had it on my network and talking on DStar. It's not difficult to do. Or you can go to eBay and just buy them pre-programmed in a box with a display. You plug USB micro in it. I think it's about $90. And that way you put that in your bag, put your handheld in your bag, and go travelling on the world, as long as you've got internet, you've got DMR. Okay, so I'm going to stop there for any questions. Am I going too fast? Yes, Steve?
Does anyone use simplex contacts on DMR very much?
Yes.
Okay.
Yeah, there was a guy that did a soda activation a couple of weeks ago, and he got on DMR simplex. You get about 35 to 40 k's. But he was up on top of one of the glasshouse mountains. It was quite cool. It was clear as a bell. When I'm talking to my hotspots, I just use simplex. Okay, so for those who don't know, the club has bought a digital radio. In fact, they bought 2 digital radios, but D-Star radio and a DMR. So I'm going to talk about how it's programmed so that you guys can use digital. That's what it's there for. So you can use digital, have a go. If you like it, then go and spend the money on radio. If you don't like it, then that's fine too. So how the radios are Connect Systems 800D, so that's what CS stands for. They're actually a US company. They're originating out of California, but they're made in China, obviously. But all the firmware is done in the US, so it's actually a quality bit of gear rather than some of the cheap Chinese knockoffs. It's all about zones. So each repeater is in a zone, and each of the zones contains 16 channels. So we're going back to the CV sort of days then. The way I've done it is I've channelized the talk groups. So when you change channels, you're going to a different talk group. So the VK4EA is the repeater we're using because it's the closest one. That's at Vancouver. We can just get it with the antennas we've got now. Hopefully we'll get some new antennas shortly. And this is it's set up with these talk groups. Can you all read that? So the one that we use all the time in Australia is talk group 505. So talk group 505 keys up every single repeater in Australia at once. And similarly, when someone hits the key on talk group 505 in Tasmania, he's talking to the entire VK network at once.
Keys up every D-Star?
No, just the DMR. Similarly, if you key up talk group 133, you key up the same talk group throughout the USA. So be prepared for an answer. We don't use talk group 1 because this gets insane. There are hundreds of these repeaters connected together. The thing I wanted to point out, I guess, is that these guys are user activated, the 133, 144, 153. So to get them going, you've got to change the talk group and then hold the button for 2 seconds. That then tells the repeater up the hill to go to that talk group. So by default, it's on talk group 505, and you have to tell it to go to a different talk group.
Peter, just before you get off that, just go back to the last overhead if you could. How do you know the other people aren't transmitting on a repeater somewhere?
So if you're not in the same talk group, the little green light will be on, so you can see the repeater's transmitting something, but you won't hear it unless you're in the same talk group. But if you don't hear anything, you're right to go. You're not going to talk over the top of anybody. If you're going over the same channel and you're going over the same time slot, but you're in a different talk group. So the second zone I've set up is VK4EA because there's only 16 channels per zone, so I couldn't put all the talk groups in one zone. I had to split them up into 2 zones. So the first one again is talk group 505. You can think of that as like the calling frequency if you like, so that's where you call up someone and say you want to chat. But you shouldn't be on there for too long because you're tying up every single repeater in Australia. And so don't have a long 15-minute conversation on it. You're not going to be very popular. So that's where you change to the regional talk groups. And they start with 380, where the X is the first digit of the postcode. So our talk group to use in Queensland is 3804. Answer your question. Similarly, for South Australia, 3805. The exception to this is talk group 3809, because we don't have any repeaters in Norfolk Island or Law Howe or Christmas Island or any other external territories. We use 3809 for a general chat frequency, talk group I should say, that's that frequency. 3800 is available, it'll go, I think it'll go to talk group 505, I think.
Someone was talking.
Yeah, so I said the protocol is to establish a contact in talk group 505 and then move to another talk group. Now generally, talk group 3808 is pretty quiet because there's not too many amateurs in Northern Territory.
Skill.
So you can go to any one of those, it's just not used all that much.
Why the 38?
That's what the international DMR people gave us, was 3800. So remembering that we've got to share this talk groups address space with the rest of the world. And it's limited to 5 numbers, I think, or 4 numbers, I can't remember. There's only a limited amount of talk groups to make it logical. As I said before, activate a talk group, select the talk group and key up for at least 2 seconds to give the repeater a bit of a chance to hook up. After that, you're good to go. And this is the last slide, so it's a bit hard to explain this on the slide, but under the display there's a P1, P2, P3, P4 button. It's very commercial orientated because normally you put stickers over them in the commercial world, is what they mean. I should do that. The way I programmed it is P4 to select the menu, P3 to move the selection to zone, select the zone you want, P4 again, then the up-down button to talk group select. So I've made it as simple as possible, I hope. The big thing with this system is you've got to leave breaks between your overs, because you're dealing with the internet here. And if you're talking to a talk group that's connected on the other side of the world, it takes seconds for it to propagate there and back. So you've got to leave a break, a nice long break. So 4 seconds is the absolute minimum.
Thanks for watching the video. I hope you enjoyed it. This is John, VK4BZ for the Redcliffe and District Radio Club. 7-3, see you next time.